Hello everyone, thank you for joining us in this lesson. This is a continuation of the previous lesson where we talked about the Rust ownership system. Today we will look at borrowing and how it affects your programs and the semantics around how it works. The borrowing concept is just like in real life, so it's quite intuitive. If someone owns something, let's say a book, you can borrow that book from them. And this is where the concept of borrowing in Rust comes from. In our case, a function can borrow a variable without taking ownership of it. So it takes that variable, it does modification if it is mutable variable, mutable reference, and then returns it back. And because we're passing a reference, we don't really own it. When the function goes out of scope, there's nothing to drop. It's not ours to drop. We talked a lot about ownership, how variables get dropped once they are out of scope. Let's see this in a concrete way. Now, every time a variable goes out of scope, the structure is called, and it is usually called by the drop function. So let's create a struct here, a very simple one. Let's call it car and give it a make, which is a string, and a speed, which is an i32. So all I'm going to do here, just to illustrate the drop mechanism, I'm going to implement, or I should say probably override, the drop function for this type. And the way to do that is just to make sure that you've got the drop function implemented correctly. And I'm just going to call here println. I'm not going to do anything fancy. I'm going to call println and I'll say car is dropped. Okay, great. So now let's go to our main function. Let's declare first car in the scope. Another 80. Let me just make this a proper string. Okay, and then I'll go in here and do car2, and that opens a brand new scope. $220. Gonna println here. Now after line 18, car2 gets dropped. We should see the message at line 8. In fact, we'll do something interesting here real quick, so we know which car is being dropped. And remember, because we have a mutable reference to self, we can actually just use the dot mechanism to dereference a specific instance of car. Call make variant there. Okay, that looks good. And now let's just copy this real quick, and we'll print car1. And then straight after line 20, you should see how car1 is also dropped. So now, if I run this, we should see a few messages. Car is dropped at Nissan. After line 18, car2 gets dropped straight away. So it goes out of scope, and that's denoted by the curly braces here. And then after line 20, car1 also goes out of scope, and this message is displayed. Hopefully this illustrates how ownership works and the dropping mechanism when it gets called. Okay, now let's move on to the main lesson. Just to refresh our memory, let's type the same function that we had earlier, which is called take ownership. And we'll pass that the parameter string as is, and we'll just do println here Okay, now if I were to define a quick variable here, call it my name, okay, and then I'm gonna call the actual function, and I will try and use my name later on at line 4. You will notice that the borrow checker and the ownership system kicks in here, and it will not allow me to compile this successfully. And the reason for that is because that function called take ownership has taken a full ownership of the actual variable called my name, and when it went out of scope at line 9 straight after println, it was no longer valid and the drop function was called. And of course when I came to line 4, it's no longer valid. One way to fix this, just as we've seen in the previous lesson, is to call the function by reference, i.e. create a function and have a parameter as a reference. And I'm just going to pass a reference here. Again, a reference is denoted by an ampersand. The opposite of a reference is dereferencing, and this is denoted by the star. You won't see that syntax very often, but it's probably worth knowing this. And let's run the program. This function now is not taking ownership of my variable because I'm passing it by reference. Now we need to modify our function since it's not taking ownership anymore. So let's do something more meaningful with this function. Let's call it modify by reference. Okay, so now let's say I wanted to modify this variable without having this function taking ownership of that variable. What I would need to do, as we've learned in lesson 1, we need to make this variable mutable so we can modify it later on. And of course in our function here, the parameter needs to be reference mutable variable, just like so. We'll add the keyword here. And let's do something a bit more interesting with this variable. And we'll give this a run, and you should see Yamcha hyperbolic in full. Now, before we move any further, it is important to note here that the referencing and the borrowing rules are very strict. For example, you can only have one mutable reference to a piece of data in a very specific scope. Let me give you an example. If I were to create a variable here called ref1 and maybe have a mutable reference to my name here, and I'll create another one here called ref2 and have a mutable reference again. Now this will automatically have an issue because let's read the error in fact first, and then I'll explain why. The reason for this is that because we don't want to have two pointers that access and potentially modify the data at the same time. This is where race condition comes in, and data races and all that sort of things that happens when you have multiple references to the same data that can potentially be modified. As I mentioned by the rule earlier, if you still want to use two different references, it's probably worth creating a brand new scope. So remember, you can create a brand new scope by including your variable in these open and closing braces, and then maybe you can do something interesting. For now we'll just print it ref2, and then you can come here and still use ref1 reference 1 without any problems. But before we can use ref1, we have to move line 3 to line 8 to line up the scopes. Now if I were to run this again, because we have this enclosed in a specific scope by itself, it's okay to borrow a mutable reference on this variable at line 2. After line 6, ref2 goes out of scope, and then you can borrow another mutable reference to the variable defined at line 2. So remember, only one mutable reference per scope. Another rule here to bear in mind is you cannot have a mutable reference while having an immutable one at the same time in the same scope. Let me illustrate. Let me clean this up real quick. Remove all this. We no longer need this function. So I can have ref1 as an immutable reference to the my name variable, and I can have ref2 as an immutable reference. Now ref3, however, I cannot have that as mutable reference because if I do that, I could have a risk of having my variable defined at line 2 be modified without me knowing. I have declared ref1 and ref2 explicitly to be immutable in this scope, knowing very well that they will not change. Having ref3 at line 5 will expose me to data changing beneath my feet, essentially. If I look at the error here that Rust gives me, it is very explicit, and Rust does not allow you to have a mutable reference while having immutable ones in the same scope. So let's give that a run, and you will see that the error here cannot borrow my name as mutable because it is also borrowed as immutable. So how would we fix this? So the first thing to do is move the println macro from line 6 to line 5. That way we know, the compiler would know that ref1 and ref2, they will drop out of scope straight after line 5, and then you can go ahead and do what you need to do with ref3, knowing full well that its purpose is now complete and there is no risk of having the data modified underneath you. Okay, done this way, it will work. Now, just to summarize all the rules that we've talked about, at any given time you can only have either one mutable reference or any number of immutable references, and references must always be valid. The key here is to remember that it's a combination of variable referencing and scoping. As you can see in this program, we do actually have multiple immutable references and immutable reference, but as long as we're scoping it correctly, we should be fine. Ref1 and ref2 are not used after line 5, so it's okay to go ahead at line 6 and create a mutable reference. But of course, if I were to come here and try and add ref3 at line 5, then there is a risk here in this scope at least that the data, my name variable, will get changed while you're expecting it not to. Well, this is it for this lesson. Thank you for joining us, and I hope you enjoyed this. If you could, please do subscribe or like the video. I'll appreciate that very much.